Hello, we'll be going over the 6.10 approach ramp, stage 3, prepared by the 2024 Florida Atlantic University Bridge team for the Cabo Dali suspended pedestrian footbridge in the Kingdom of Sotini. We're going to go over the outline and required equipment and materials. First, we're going to coat an embedded portion of cable with roofing tar or asphalt paint. Paintbrush, gasoline, and roofing tar will be needed. Next, we're going to complete ramp fill with rocks and 30 centimeter lifts. On the top of each lift, fill voids between rocks with smaller rocks and cover with a layer of concrete slurry. Fill must not exceed 3 lifts per day. We're going to need river rock, as seen in an image in the bottom portion of the screen to the left-hand side, or gibbon stone, as seen in the middle image. River sand, sand sieve, 50 kilogram cement bags, seen on the right-hand side. Spades, buckets, 5-meter measuring tape, spray paint, and tamping rod. In this case, the river rock was locally collected by the community. The gibbon stone and the 50 kilogram cement bags were acquired by the municipality, in this case micro projects through the Kingdom of Sotini. Next, we're going to cast a minimum 10 centimeter concrete topping slab over the ramp surface. The 10 kilogram cement bags, river sand, are also used on ramp fill, but the difference is we're going to use a concrete mixer if available, wheelbarrows, galvanized wire mesh, and bricks. In the image to the left-hand side, you're going to see the concrete mixer. You're also going to see the gravel and the bricks. On the right-hand side, you're going to see the river sand that's being passed through the sieve, and also the galvanized wire mesh. Next, after curing, we're going to cut the contraction joist in the concrete topping slab using a circular saw with a concrete blade or a pointing trowel. Next, we're going to cast the concrete topping between towers over a walkway hump. We're going to use the same materials used for the concrete casting topping slab. Next, we're going to use the automatic level to record the as-built dead load sag of the completed bridge using the automatic level and the tripod. Finally, we're going to use a spray paint to mark the handrail cables at the center of the saddle and walkway cable at the opening of the walkway hump tube. In the beginning, we need to coat the embedded portion of the cable, and you can see here in this image that's being done using the bucket, but it is recommending using a cup, so you could distribute the roofing tar to different cups, and you're going to use 2 cups, 2 paintbrushes, gasoline to be able to do it at the same time. The gasoline is to take off the roofing tar from the brush if not being used. You're going to coat the entirety of the cable from the whole perimeter of the cable within the abutment and a half meter above the top of the concrete cap. In this image, you could see how the cable is fully coated. All the crevices are coated from the cable to ensure proper protection from corrosion. We are not going to, however, paint over the galvanized cable clamps, as the galvanized cable clamps are already protected from corrosion, but you will paint the cable in between each clamp. Next, we're going to complete the ramp fill with 30 centimeter rock lifts. And here you can see the spray paint was used to spray 30 centimeter lifts from the bottom of the anchor going upwards on each wall within the perimeter of the abutment, so it could be seen throughout the abutment, each 30 centimeter lift. This is a good image representing the top of one lift, how the rocks are spread out evenly throughout the entire lift. And now you're going to see the slurry or the concrete slurry being put on top of the lift to then bind this whole lift together, and hopefully use a tamping rod if necessary to put the concrete slurry within the cracks and crevices of the abutment fill. Finally, at the top lift of the last layer, we're going to use gravel to plane the whole surface to make it ready for the concrete topping slab. This was just a quick video showing the fill of the abutment using a rock line. 2B, we're going to go over the guardrails as specified if the abutment is taller than 1.8 meters. These will be required. And here you can see the completed version without the fencing. And we're going to go over how the guardrail posts need to be 30 centimeters deep from the top of the ramp walls or 40 centimeters deep from the top of the finished approach ramp slab. In this video, you're going to see how The hole was initially made just by clearing the area out and moving the rocks out to make a 30 centimeter to 40 centimeter hole. Then was filled with concrete, and then the pole was placed and made sure level.
He doesn't want to do it from the ground.
Here you can see in this image on the right hand side, the black line on the pole represents the distance from the edge of the pole, 40 centimeters, to that line marked, to make as a reference to put at the same level as the string line being placed, 10 centimeters away from the tower. And this is a good reference so the mason knows how deep the pole should be in reference to the top of the slab. Here, the field engineer in charge in our project would say I would be the human clamp. So I'd hold the pole in place for a good duration, probably 3 to 5 minutes, to make sure the concrete cures so that it could hold the pole within itself. Next, the farthest pole will be placed with the string lines as reference away from the brick form, and also a desired length away from the first pole. And the string line is placed on top to reference the poles that are going to be placed in between to make sure that they're at the correct height. And now going into the casting of the minimum 10 centimeter concrete topping slab, we're going to first gather all the materials needed for this project, for this phase, because this is a very extraneous process that's going to require the entire day, at least on one side, if not both, with enough manpower is given. And we're going to require all the gravel, river sand, cement bags, wire mesh, buckets, etc. And you can see here on the right hand side the image they're gathering the wire mesh to be placed on top of the gravel. And you're going to want the mixed materials to be in a consistent pace so they don't cure too fast if you're not going at enough pace, and switch mixing groups throughout the day. Here the galvanized wire mesh is already placed on top of the gravel, being ready for the concrete to be poured. Here the concrete mixer is being used and cement is being placed in. At the same time, gravel, sand, which is out of frame, and the cement bags behind, and the water is on the back right behind the concrete mixer. And we marked it here. You can't properly see it because the image is a little poor, but we calculate how many shovels it takes to fill in volume compared to 2 cement bags, but we realized 2 cement bags was too much for this concrete mixer. To get a proper mix, an even mix, it's probably best to do 1 cement bag volume mix. And here you can see the image of a wheelbarrow filling up the first pour of the concrete topping slab. This video shows in the case if you don't have a concrete mixer. In our specific project, we only had a concrete mixer on the right hand side but not the left hand side, so the concrete had to be mixed by hand, and a bucket concrete line had to be made to the abutment to then pour the concrete in bucket at a time. This is the final thing that's usually done before cutting the contraction joint, where the masons take a very long 2x4 and run it across the top of the concrete slab to make it plain and take off the excess concrete. And they're going to then go over with a concrete trowel to then flatten it out nice to get a good finish. And now, after curing, you're going to cut the contraction joints in the concrete topping slab. The circular saw and the concrete blade at a maximum width of 1/8 of an inch or 3 millimeters, with a depth of 1 inch or 25 centimeters, space approximately 3 to 5 meters. In our case, we didn't have a circular saw or a concrete blade, so what the masons did here is they placed that same 2x4 you saw in the previous video, placed it across where they needed the marking to be, and then took a pointing trowel and then scored the concrete to make that contraction joint at that required dimensions. For these two red rectangles, demonstrate where the lines is if you can't properly see it. Next, we're in the cast concrete topping slab between the towers over the walkway hump. You can see here this is one of the first pours being placed from the wheelbarrows to cover the concrete topping slab. This is typically done during the 10 centimeter concrete topping slab, and here you can see the forms that are used. The decking is also part of the forms. There's a wood form that's being placed underneath the decking. On the right hand side you can see the wood form. Then they cut out a slot within this 2x4 to get the decking through and hold back the concrete, and this has to be properly reinforced so the weight of the concrete doesn't push it out. Next, you're going to use an automatic level to record the dead load sag from the completed bridge. This is done when all the dead load is placed on the bridge, all the fencing, all the screws, all the decking, all the cross beams, all the things that are going to be required for the completion of the bridge. And we're going to reference back to when you did the design sag and you marked your values on the tier or somewhere off the tier if the midspan reached below that point. You're going to find a location so you can see that reference mark, and the bottom of the walkway cable is that high elevation to initially place the tripod. And these red circles represent what we did. So on the right hand side it was our marking on a duct tape of the design sag, and we went off to that left hand side red circle and placed our tripod there to see the reference from the reference mark and also the bottom of the walkway cables. And we're going to use that comparing the design sag to the dead load sag to see how much it changed, how much the dead load took an effect on the cables. And this will vary at the time of day. If you did it in the morning, the cables will contract because of the cold temperatures at night and then expand during midday when the cables get hot. And here's just an image of how to properly look through the optical of the automatic level. You don't want to touch the tripod or disturb the air around the tripod to disturb the levelness of the tripod and the automatic level. Next, we're going to use spray paint to mark the handrail cables at the center of the saddle and the walkway cables. And you can see here, this is where the walkway tubes come out. This is our field engineer and the intern from EIA. And you're going to see it's not spray painted. We unfortunately didn't get any pictures of the spray painted marks, but you will spray paint perpendicular to the cable at the entrance of the tube. And also here you would spray paint at this mark perpendicular to the cable at the top of the saddle point. And this is done to reference to see if the cables have moved from behind the saddle point within the abutment. The cables will expand and contract within the midspan, within the span of the bridge, but you don't want any contraction or expanding within the abutment, and these marks will show if that has happened. Thank you for your time.